The exact authentication process used by Identikey server depends on settings in the policy and DigiPass user account. This diagram shows the basic process when authenticating a DigiPass user login. A client record must exist in the data store for any client application sending an authentication. The application making an authentication request will be identified using the client type and client location. Client type is a name provided by the SOAP application, or a fixed name such as Radius Client, Citrix Web Interface, Outlook Web Access or Administration Program. Client location is the source IP address of the request. SOAP, originally defined as Simple Object Access Protocol, is a protocol specification for exchanging structured information in the implementation of web services in computer networks. It relies on extensible markup language as its message format, and usually relies on other application layer protocols for message negotiation and transmission. In most cases the transmission is done by HTTP or HTTPS. SOAP can form the foundation layer of a web services protocol stack, providing a basic messaging framework upon which web services can be built. Identikey has 5 web services. These are user authentication, signature validation, administration, provisioning, report generation. This is an example of SOAP authentication request. Written in XML and transported by HTTPS. Identikey server can be used in Radius environments to handle the authentication part, which is only one functionality of the AAA capabilities of Radius. AAA stands for authentication, authorization, accounting. Even in this one environment, multiple configurations are possible. Radius attributes are data elements that are sent between the Radius client and the server. The attributes are mainly used for authorization. Here we use check attributes. Example, the dial-in number, used by the client. If the dial-in number is not authorized on the Radius server, the authentication will fail. Client setup. These are apply attributes. Example, the Radius server will send the IP connection details, like the IP address to be used by the client, the subnet, etc. Configuration management. Example, there are VPN servers in the market which will do a login on a Radius server, just collect their setup details as vendor-specific attributes. Any Radius server knows a list of default attributes. These attributes are stored in an embedded dictionary. Many network vendors use specific attributes to configure their equipment remotely. These vendor-specific attributes are stored in a vendor-specific dictionary. The Identikey can load a Radius dictionary. Authentication between the user and the client uses point-to-point protocols such as PAP and CHAP. PAP is a simple authentication protocol in which the user name and password is sent to the remote access server in a plain text form. Using PAP is strongly discouraged because your passwords are easily readable. PAP is typically only used when connecting to older Unix-based remote access servers that do not support any additional authentication protocols. CHAP is a widely supported authentication method in which the knowledge of the user's password, rather than the password itself, is sent during the authentication process. With CHAP, the remote access server sends the remote access client a challenge string. The remote access client uses the challenge string and the user's password, and computes a message digest 5 better known as a MD5 hash. Hash functions or algorithms are known as one-way encryption because it is easy to calculate the hash result for a block of data, but it is mathematically infeasible to determine the original data block from the hash. The MD5 hash is sent to the remote access server. The remote access server, who has access to the user's password, performs the same hash calculation and compares the result with the hash sent by the client. If they match, the remote access client's credentials are considered authentic. Microsoft created MS-CHAP to authenticate remote Windows workstations, providing the functionality to which LAN-based users are accustomed while integrating the hashing algorithms used on Windows networks. Like CHAP, MS-CHAP uses a challenge-response mechanism to keep the password from being sent during the authentication process. MS-CHAP uses the message digest for hashing algorithm and the data encryption standard encryption algorithm to generate the challenge and response, and provides mechanisms for reporting connection errors and for changing the user's password. Microsoft point-to-point encryption is a protocol for encrypting data across point-to-point protocol and virtual private network links. It uses the RSA, a C4 encryption algorithm. MP supports 40-bit, 56-bit and 128-bit session keys, which are changed frequently to improve security. The exact frequency that the keys are changed is negotiated, but may be as frequent as every packet. Extensible Authentication Protocol, or REAP, is an authentication framework frequently used in wireless networks and point-to-point connections. It is defined in RFC 3748, which made RFC 2284 obsolete, and was updated by RFC 5247. IP is an authentication framework providing for the transport and usage of keying material and parameters generated by IP methods. There are many methods defined by RFCs, and a number of vendor-specific methods and new proposals exist. IP is not a wire protocol. Instead, it only defines message formats. Each protocol that uses IP defines a way to encapsulate IP messages within that protocol's messages. IP was originally designed as part of the PPP, point-to-point protocol. The PPP Extensible Authentication Protocol, IP, is a general protocol for PPP authentication which supports multiple authentication mechanisms. It was developed in response to an increasing demand for remote access user authentication that uses other security devices. By using IP, support for a number of authentication schemes may be added by defining IP types. Support might include token cards, one-time passwords, public key authentication using smart card, certificates, and others. IP hides the details of the authentication scheme from those network elements that need not know. For example, in PPP, the client and the AAA server only need to know the IP type, and the network access server does not. IEEE 802.1x is the denotation of a standard that is titled Port-Based Network Access Control, which indicates that the emphasis of the standard is to provide a control mechanism to connect physically to a LAN. The standard does not define the authentication methods, but it does provide a framework that allows the application of this standard in combination with any chosen authentication method. It adds to the flexibility as current and future authentication methods can be used without having to adapt the standard. One such an authentication method is IP. IP simply provides a conduit between the authenticator and authentication server where they discuss the best way to authenticate and then actually go about the task of authenticating. Since IP itself is merely a conduit, it can be thought of as a computer's operating system. An operating system in itself is useless without applications to execute. IP types provide these applications by providing the authentication protocol used to perform the actual authentication step. In this way, future authentication protocols can be easily added by adding new IP types to the authenticator and supplicant. 802.1x authentication involves three parties: a supplicant, an authenticator, and an authentication server. The supplicant is a client device, such as a laptop, that wishes to attach to the LAN/WLAN, though the term supplicant is also used interchangeably to refer to the software running on the client that provides credentials to the authenticator. The authenticator is a network device, such as an Ethernet switch or wireless access point, and the authentication server is typically a host running software supporting the radius and deep protocols. The authenticator acts like a security guard to a protected network. The supplicant is not allowed access through the authenticator to the protected side of the network until the supplicant's identity has been validated and authorized. An analogy to this is providing a valid passport at an airport before being allowed to pass through security to the terminal. With 802.1x port-based authentication, the supplicant provides credentials, such as username, password or digital certificate, to the authenticator, and the authenticator forwards the credentials to the authentication server for verification. If the authentication server determines the credentials are valid, the supplicant is allowed to access resources located on the protected side of the network. Note: the usage of IP or BIP, TLS or TTLS is defined by the client. When deploying an Identikey server in an existing topology, you will have to check what has already been configured at your customer. IAP provides some common functions and a negotiation of the desired authentication mechanism called methods. Commonly used modern methods capable of operating in wireless networks include DEEP-TLS, BIP, LEAP and DEEP-TTLS. Note: when you have a Cisco wireless access point, it is set up by default with the fast HEAP protocol. The Identikey can still be used for strong authentication, if there is a Cisco Radius server in place. The Cisco Radius server will have to use the Identikey as its back-end server. Wireless sessions may be renewed at regular intervals by using Fast Reconnect. When an OTP authentication is performed, a session ID is assigned to the wireless connection. A Fast Reconnect uses this session ID to automatically re-authenticate the wireless connection rather than requiring user ID and one-time password input from the user. The session ID is the name of the network. A lot of NAS clients talk directly with the Identikey server. Typical examples are Checkpoint, WatchGuard and other third-party products requesting DigiPass authentication to the Identikey server. If authentication is the only required functionality, then no additional Radius server is required in the architecture. In this scenario, Identikey server will forward requests to a Radius server in order to retrieve authorization attributes, after validating the one-time password. It is necessary to provide a static password to the Radius server to achieve this. Therefore, there are two methods of implementing this. Method 1, login with OTP only. Using this method, the user only enters his OTP. Identikey server is to learn the static password for the user, so that when the user gives the correct OTP, it can send the static password to the Radius server. Method 2, login with password and OTP. Using this method, the user enters his static password and OTP at each login. Identikey server validates the OTP and if correct, forwards the static password to the Radius server. In this scenario, a Radius server acts as a proxy for authentication, effectively delegating the authentication process to Identikey server. The Radius server provides the authorization attributes after Identikey server has accepted the user credentials. Not all architectures are suited for all protocols. Because CHAP and MS-CHAP hash the password and OTP inseparable together during encryption, all features in which a user has to provide both in the same request cannot be supported in the architecture where the Radius server acts as a backend. Some of these features are listed above. In a web environment, Identikey server uses a component that plugs into Internet Information Services to intercept authentication requests. This component, the IIS module, verifies the credentials with Identikey server first. Normally this means verification of the one-time password. If the OTP is valid, the static password is given back to IIS as if the user had entered it, and the normal website authentication process completes the login. This IIS module can be used for IIS, Outlook Web Access and Citrix. More information can be found in the online training for DigiPass authentication for web interface. Other modules that communicate with the Identikey server using the SEAL protocol are the DigiPass authentication for Windows Logon, the password synchronization module, and LDAP sync. More information about these modules can be found in the online training DigiPass authentication for Windows Logon, Password Synchronization Manager, and LDAP synchronization. Fill in the proper values to create the new client. The client type is a required value. You can select this by using the Select Client Type button. In case of SOAP, this will be the credfield_component_type element. The location will be the IP address of your client. If your client is of type Radius, this must be the NAS IP or NAS ID. Select the proper base policy and protocol ID. Click Create to continue the process or Cancel to stop the creation. The DigiPass info is displayed here. You can click on the Edit button to change this info, delete the DigiPass and assign the DigiPass. Or take a deeper look on the application. When editing a DigiPass, you can change its description, reserve it for individual assignment, and set up the backup virtual DigiPass parameters.